Now.
Welcome, everyone. I think we can get started now. I'm Tony Roskilly. I'm Professor of Energy Systems at Durham University and a Director of Durham Energy Institute. This event is organized through the EPSRC network, which is for hydrogen fuel transportation. And this is part of a series of webinars associated with hydrogen research and development in the transportation sector. So this week we welcome two speakers who will present the challenges of introducing hydrogen transportation from an industrial perspective. Speaker is Dr. Harsh Pershad. He is head of hydrogen at Tevva Electric Vehicles, or Electric Trucks, sorry. Harsh gained his first degree in chemistry at Imperial before doing postdoc research at the University of California and then in Cambridge, and returned to Imperial to complete an MBA. He's previously worked for Element Energy, BEIS and Innovate UK as a senior innovation lead for energy before moving to his new role within Tevva at the start of the year. So over to you, Harsh.
Thank you very much, Tony. I hope you can hear me okay.
Yeah.
Great, thank you. And it was a real pleasure to hear Paul Andrew speak about Oaktech's status now. As Tony was saying, I used to work at Innovate UK. I had a chance to meet Oaktech at the beginning of their journey, and it's lovely to see how far you progressed with that. So as Tony said, I'm Harsh Pershad. I joined Tevva at the beginning of this year, and long-standing interest in energy, and my PhD was on electrochemistry, and so I've been really fascinated by the different approaches we can get to energy transformations. Sometime around 2005, I read one of the earlier IPCC reports on climate change, and managed to convince myself that there was a meaty problem to get my teeth into. And so that's when I left academia and I joined a consultancy specializing in zero carbon strategies called Element Energy. Found myself repeatedly drawn towards emerging technologies, things like hydrogen, CCS, electrification, but often limited by the need to match infrastructure over different locations and timescales and capacities, and the need to really work with people in a very inclusive approach to infrastructure development, because consumer behavior or stakeholder behavior in terms of allowing for planning and things like that is actually far more influential than all of the kind of spreadsheet work we were doing on efficiencies or costs of systems. And I thought that's quite an interesting space, and it's one that I noticed when I was working at Innovate UK, had a chance to try and build in much deeper links with different stakeholder groups, so central government, local government, energy companies and technology developers. I think the most success we had was with our industrial strategy challenge funds, which really kind of put a fire under some of the industries of the future. And it was good to hear about the HyNet project just referenced, because that came out of the industrial strategy challenge fund called Industrial Decarbonisation, bringing hydrogen and CCS together in a very coherent wrapper. It's very exciting. I think there's a lot of growth opportunity. Talk through now what am I going to be talking about today. I'll set the scene with the government's net zero strategy estimates of different energy flows. And then I'll go from that really big picture for what things might look like in 2050 to what's become a big picture for me, but on that scale is perhaps quite small. And that is, what does a technology developer, a business, need to do now in order to realize that opportunity? So I'll be talking about some of the challenges that I'm experiencing now on a sort of day-to-day basis in growing the energy supply for Tevva's zero emission trucks. So just before the pandemic, just to set the scene, here's our most recent Sankey diagrams for energy flows across the economy. Left-hand side, all the different supplies. Right-hand side, all the different end uses. Vast majority of those, you can see in grey, are the fossil fuels. And at the top, a little bit of bioenergy. Electricity generation, about a third of that, and most of that going into buildings and industry. But if we fast forward and the each of the kind of the really big wedges are about 100 terawatt hours each. So we've got overall of the order of a few hundred terawatt hours of energy across the economy each year. If we fast forward now to 2050, the actual amount of electricity in some of these scenarios is actually bigger than the entire amount of energy flows that are currently going. So potentially 600, 690, I think, in this particular picture, just really high levels of energy flows, the majority of which coming from wind and nuclear. You can see in red the bioenergy. In purple, you can see electrolysis, and there's really important to understand there that it's not that it's electricity or hydrogen, but that in order to manage very high levels of renewables, wind and solar, then there's a really firm need for electrolysis. And this is in the government's own high electrification scenario. So the one where they're least favorable towards hydrogen actually still has huge amounts of hydrogen overall. And I think that's important to set that, because people are often worried about, well, what's the efficiency of hydrogen production? And actually, if you need to make the hydrogen to make the best use of your wind, then that's the focus on the efficiency of it at that early stage is probably actually not that important. So I just wanted to just set that context. There are other scenarios that BEIS published. This is one which is with even higher levels of hydrogen in it, and a third one where a lot of that hydrogen is kind of coming through natural gas with CCS. So quite a few different 2050 scenarios, which are all least cost or least risk or most politically acceptable. These are they all have a large level of zero carbon electricity and hydrogen. So the hydrogen is going to be around anyway. So that's useful to understand that. And electricity growth, huge amounts of electricity growth, are really, really fundamental. Now I'll dive into our company, Tevva. Tevva's 9 years old, founded by Asher Bennett, and it's a company that's a technology company. We've been building battery electric trucks for a while. We're on our third generation battery electric truck, getting lots of investment. I'm sure most of you are aware it's a great time to be raising private investment in low carbon, which it hasn't been for a very long time. So it's great that things like COP26 have really made a difference to the amount of global interest in zero emission solutions. We've got a lot of people who've come from the transport sector, so people who were in conventional ICE, diesel-fueled ICE systems have kind of come over to come and work with us. There's some people there. Lots of different groups have kind of concluded that whether you're looking on a cost basis, which is the horizontal axis, or the carbon basis, which is the vertical axis, trucks are potentially a really good use of hydrogen. They are currently, however, very much limited by the availability of the trucks and the availability of any hydrogen. And we have a solution, which is a hydrogen fuel cell range extended battery electric truck. So we've been selling, our 7.5 ton electric trucks have been on the road for several years now. And we're soon to be launching our much longer distance, 200, 300 mile trucks. And what's really exciting about those is where the battery trucks are good, short distances, the fuel cell range extended ones can really tackle the majority of truck energy demands. So whether that's high payloads or long distances, or both high payloads and long distances, in the 7.5 ton to 19 ton truck market, where we're one of the only providers. The model is, as I said, range extension. So you have batteries which are nearly always used because electricity is currently much cheaper than hydrogen, and you have hydrogen tanks which may be used in some of the time for the largest trucks, probably much more, but really use software then to manage the best source of energy for each journey. And we've got our own battery packs and software management systems. Like any OEM, any original equipment manufacturer looking to grow our fleets over time, these are different vehicle types and the amount of energy that we might need for those. I've taken off the axes for commercial reasons, but the numbers of vehicles that we're looking to scale are definitely in the thousands to tens of thousands within 5 years, for example. They need both hydrogen and electricity. And that brings us to a really interesting set of challenges. I showed you a picture of the 7.5 ton truck. We're also launching a 12-ton 19 truck over the next year as well. Each of these, in this weight range, 7.5 ton to 19 ton trucks, a lot of the trucks stay at a customer depot overnight, and that feels the best location for electric charging and probably for hydrogen refueling. And it'd be quite interesting to explore then, what does that mean in terms of numbers of stations over time? So if we look over the next 5 years, we expect to see hundreds of different depots that need to be set up with both charging and hydrogen capabilities. And that might be behind a fence where existing customer owners manage that with daily back-to-base refueling. That model it's quite attractive, but then requires capability and space on site, can be constrained. Some could be over the fence where you're clustering vehicles quite close together, and some of it might be with shared refueling networks. And that's probably most likely for hydrogen or really fast charging. But that then leads to a question about, well, if you're doing work at depots, typically people aren't going to suddenly swap over all their fleet. How do you phase up? Well, should you phase the growth of energy infrastructure, or should you future-proof from the beginning? And each time you go in and add in some new charging capacities, it takes time, adds cost, and there's a lot of disruption there. So particularly if it requires any digging up for cable laying, or if you're putting in any fixed facilities for, say, on-site hydrogen production. Probably at the beginning, you can use a lot of existing infrastructure and small mobile refueling solutions. But over time, to get the best economies of scale, you need to grow from fairly small depots up to depots where essentially hopefully you've phased out diesel vehicles within, well, by the end of this decade. There are a lot of companies that are really keen to phase out their diesel commercial vehicles as quickly as possible. So that's a challenge, is how to grow that over time. Today's technologies for small scale refueling are mostly these kind of cylinder packs. They're transported on back of lorries and delivered to sites. And that's fairly practical, quite well-known approach. It's getting better and better. And the actual act of refueling, for those of you who aren't familiar with it, is very similar to refueling a regular vehicle and designed as such. And the protocols for commercial vehicles aren't yet as good as those for passenger cars in terms of hydrogen refueling, but they are getting, there are working groups to try and work out what are the next steps with those. And for the largest fleets, then on-site hydrogen production is possible. That's where the economics stack up best, is when you're making quite a lot, then compressing it locally. These pictures from Aberdeen, where their bus depot has been operational for some time now, and they produce the hydrogen on site. The change from diesel to electricity and hydrogen requires, though, is then many different touch points for customers with energy that they're not used to. So how should a truck manufacturer like us support those customers to access the energy they need? Because obviously we've got a vested interest in making sure that they have our trucks. So it's quite interesting to work out how do you facilitate the use of truck without kind of overloading your customer with so much pain that they get put off because they don't know what options are available. They don't know, they haven't had conversations with their electricity provider, with the planning authorities nearby, with their neighbours on, or even between different parts of their operation. Fleets are not just one size vehicle. There could be quite a lot of different ones. How do you plan for how and where you put in chargers and refueling infrastructure, what information needs to flow and between whom, how much do you contract, and how do you match those contracts with the vehicles and the usage, and how do you ensure that when all that goes on site, that's a positive experience and doesn't dissuade people from adopting electric vehicles or hydrogen vehicles. So how do you align all the training and the comms for customers? These are things that they just don't have to worry about with diesel. They don't have to worry about charger maintenance, but anybody who's got an electric car, I've got a plug-in hybrid, knows that chargers do seem to go down an awful lot. And also hydrogen refueling stations, they're getting better, but the older ones certainly weren't that reliable. And so how do you make sure that their customers feel this positive reinforcement as they move towards zero emission fleets? And of course, you look ahead, and often people buy vehicles thinking about what's the residual value at the end of this, and what am I going to do at the end of this? Who's going to buy it? Am I going to be left with stranded energy infrastructure? Or they could be actually left with positive infrastructure that enables further decarbonisation if you future-proof it. So there's lots of different touch points that logistics companies just have never had to deal with. And I think that's a really interesting disruption to that market. Some of our challenges, anybody who's been in this sector knows that there's an enormous gulf between EV fans and hydrogen fans, and it's very tribal, and very few people are comfortable with the various ways of making electricity, the various ways of making hydrogen, the best ways of matching where you make and how much you make with what you need and when you need it. How do you take a fairly conservative sector like commercial vehicles, where people have just bought outright, they've kind of then severed their links with their suppliers? How do you change that to a model where you've got more integrated services? In terms of just locations, should we choose places where we've got lots of energy infrastructure? So in the north of England, it's much easier to get grid connections, much easier to get hydrogen. We think with, for example, all the great proposals for Teesside and the Humber area. But at the moment, things like the clean air zones are in big cities, for example, around London. And so there's a kind of a question about where do you site to grow? Do you take a demand-led, do you take an energy supply-led question? And also, what are other people doing? If lots of people cluster around a place, the economies of scale and the capabilities just get so much better. Coordinating volumes across both electricity and hydrogen and vehicles, and then end users. This is quite a challenge, one that any individual company would struggle with, but there doesn't yet seem to be any one-stop shop or kind of organization for both the EV sector and the hydrogen sector to together coordinate the growth of low carbon energy for decarbonizing the transport system. Going back to that site-specific question, do we want to do lots of small interventions? Do we want to try to encourage future-proofing from the beginning so that we get the right size infrastructure, and who pays for the cost if there's a difference there? Obviously, like any company, we're trying to grow rapidly. Last year, Tevva started out the year with 40 people. We're now 170. We're looking to double that almost every 6 months, and we're already outgrowing some of the facilities that we've got, and trying to work out how do you grow businesses rapidly in the UK. A lot of net zero businesses are going to be growing rapidly, and I think that there's a bit of a shortage in trying to work out where does the public sector, for example, help with that. And of course, there's huge uncertainties. It's very hard to get any kind of forward hydrogen price contract at all, let alone any kind of location specific one. Electricity, everybody knows how volatile that is at the moment. And it's hard to invest when you're not sure whether later on a market may be tightly regulated. If the gas networks do switch over to 100% hydrogen, then there'll almost certainly be an economically regulated model. So what does that mean for people who've invested now in refueling stations, and how might that change between countries? So there are quite a few areas that, frankly, I'd welcome this audience's support for progress. I think I've taken up more than my time, so I shall stop now and look forward to any questions.
Okay, thank you very much, Harsh.